you're interested in expanding your universe, each one of them will have something that's interesting and new.
It all takes place in the space of less than an hour.
The questions were very knowledge-based. Take the work hat off, look at something cool, and think about things in a different way.
Okay, thanks Ian. Your 20 minutes starts now.
Thank you very much, Martin. Cheers. So, quick introduction to Global Energy Group first of all. Global Energy Group is a multi-energy company. We traditionally, obviously back in the early 70s, 74 onwards, the company was almost exclusively focused on the oil and gas sector. But over the last, in fact, since 2004, the company has started to diversify its business, and today, as of 2019, renewables probably makes up about 25% of Global Energy Group's turnover. That's probably going to increase as a percentage. Obviously, with the current situation with COVID-19, the oil and gas industry is in a downturn, as we all know. So I can see that the percentage of the renewables is going to grow even faster than it was previously predicted. Just in terms of some of the sectors that we currently work in oil and gas, obviously we've been very heavily involved for many, many years doing fabrication of very large structures, but we also still have the capability to do smaller fabrication and maintenance and repair activities. So we've got a rig inspection, repair and maintenance business. Back in 2015, we did our last major project, which was an FPSO refurbishment for the oil and gas sector. And we've also got a marine logistics capability. So this is something that we developed as part of our offering to support the renewable energy business back in a few years ago. And I'll talk a little bit more about the investments that we've had on the plant as we go through the presentation. So current activities in oil and gas include working on the kind of operational activities of oil and gas projects. So we do a lot of survey work, we do light engineering work, fabrication, construction of various components in the oil and gas industry. We've got rope access specialists and pipe work and structural engineers. So quite a wide varied capability within the group. Last year, in 2019, Global Energy Group acquired a company called Apollo Offshore Engineering, who are based in Aberdeen. Now, Apollo's been around for a number of years now and has a very, very well-respected client base in the renewable energy and the oil and gas sector. And so bringing together the skills and competences of Apollo, which provides the offshore design engineering capability, along with the construction and fabrication capabilities of Global Energy Group, gives the group as a whole the capability now to start looking at full engineer procurement and construction type projects. And if anybody's got any questions on Apollo, I'll happily answer those towards the end of the presentation. So I just want to take a few minutes to give you a bit of background into how I got into renewables and why I'm so passionate about this sector. So my renewables journey really started when I was working in the industrial automation business for a company called Rockwell Automation. And I was 12 years at Rockwell Automation until 2008. And during that time, one of the areas that we had a big focus on was actually energy efficiency. So in industry, we were promoting the use of variable frequency drives to try and drive down the cost of electricity usage in factories and so on. In 2008, I started a new career in renewable energy working for NAREC, the National Renewable Energy Centre, as it was called at the time. And a few years ago, NAREC, as most of you will know, merged with ORE Catapult. NAREC has blade testing and cell testing facilities for wind turbines. And that was a fantastic entrance into the renewable energy space. And around about the same time, I started really embarking upon a personal vendetta, if you like, to try and make my own home as energy efficient as possible. So we completely re-insulated our house. We topped up all of the loft insulation and cavity wall insulation and bought the energy efficient light bulbs, which a lot of people were doing around about that time. But this was really before the renewables industry had really taken off in earnest. And we certainly did see, I don't know if anybody else had the same experience, but we certainly saw a significant reduction in our fuel energy bills for gas and electricity as a result of making some of those changes. Whilst I was at NAREC, I was also very fortunate to be involved in a trial project with a company called Avid Technology, who were developing a prototype electric vehicle, and that really got me interested in the electric vehicle space as well. That particular vehicle has led on to Avid becoming a major player in the powertrain industry for the electrical vehicles market. So, tremendous success for that particular company based in the northeast of England. In 2012, I also then installed roof solar panels on my home. And in 2014, I became what they called a cluster champion for a project run by EA Technology, which was commissioned by Ofgem. And this was really about testing the impact of electric vehicles on the local grid. So that was a quick introduction to me as why I got into renewables and why I'm so passionate about this industry. And the My Electric Avenue project, I'll just give you a very quick overview of what that project entailed. It was basically looking at the challenges of large numbers of EVs on the grid. At the peak of the project, there were 219 individual households around the UK, all in clusters of a minimum of 10 clusters of users together, so that you had to have a minimum of 10 people connected to the same substation. And in the substation, EA Technology installed a programmable logic controller, which was able to control the charging of the vehicles remotely over a network. This allowed them to actually monitor the charging the vehicles, but also look at testing some new technology to control the charging and mitigate for any challenges that might occur on the grid. Of course, many EVs today are actually fitted with more intelligent charging systems. So you've now got scenarios of vehicle to grid, where the vehicles, rather than being an actual problem for the grid, can actually be part of the solution. And particularly when you mix electric vehicles with renewable energy from offshore wind, it's actually a perfect match together, match made in heaven, you could say. Just also to give you a little bit of a background as to why I believe renewables make sense, both at the commercial level, which we're going to go on to, but also from a domestic level as well. I just wanted to show you, these were the figures I took just yesterday. My solar panels on my roof have actually generated over the course of this year 3 megawatt hours of electricity. Now, if you contrast that with a modern day wind turbine, if you look at something like an MHI Vestas 9.5 megawatt turbine, one single turbine would produce the entire energy production of my solar panels in the space of just 20 minutes today. But nonetheless, it's still a fantastic contribution to the grid. And for me personally, if you look at just the performance figures for March, 285 kilowatt hours of energy generated in March. Our electric vehicle used 160.5 kilowatt hours of electricity during that whole period. So you could almost say that the electric vehicle has been charged entirely for free using sunlight. And of course, the electric vehicles are something that I'm quite passionate about. They're incredibly cost energy efficient. The cost per mile is approximately 3.5 pence per mile. And if you compare that with a diesel vehicle, you'd probably be looking, if you took an average diesel vehicle with a 45 miles per gallon, and the current petrol price or diesel price of £1.33 a litre, you'd be looking at about 14.7 pence per mile. So an electric vehicle actually is about 4 times more efficient. And this, of course, is one of the reasons why the energy industry is seeing this energy transition. People are moving away from fossil fuel transport, and they're moving into a much more energy efficient world. This report here is from DNVGL, and it just shows that the peak primary energy demand is expected to come in 2030. And what you can see on the right-hand side there is how wind, solar PV, and solar thermal solar PV technologies are becoming more and more prevalent. And certainly up to 2050, you're going to see coal almost completely disappearing off the energy supply chain. Of course, oil and gas will be here for a long time, and we need oil and gas not just for fuel, but also for the production of all sorts of plastics and clothing and so forth. So, the energy transition is a timeline, and it's not the end of oil and gas by any means. Oil and gas is going to be around for an extremely long time. However, I just wanted to show you the report from DNVGL. This is the Energy Transition Outlook report from 2019. Peak oil was predicted to happen in 2020. Actually, that should say 2022. I do apologize. It should have been 2022. However, because of the current COVID-19 situation, as you can see, that's already happened. We're now already at peak oil. Some of the other highlights in this report from DNVGL are that by 2026, transport energy should peak. And by 2033, we'll see the peak energy demand and the peak in natural gas demand from the grid. By 2015, half of the world's vehicles will be forecast to be electric vehicles, full battery electric vehicles. And this is probably for me the most important one, actually. I think from a global perspective, by 2036, 95% of the global population of the world will actually have access to electricity. So I think that that's a positive message for mankind and humankind, that the energy transition is actually going to enable some of these third world countries to catch up with us in the West. By 2018, half of the maritime energy is going to become non-oil. And by 2050, 44% of the total energy demand will be non-fossil. However, we're in a very testing times at the moment, as we're aware, and of course the COVID-19 situation is going to have a significant impact. One thing to take away from this particular graph is that despite the significant downward trend, in oil and gas oil and gas and coal demand during this period of the pandemic, renewables is actually still forecast to grow. So it's an industry sector that's going to continue to travel in an upward trajectory. If you look at the compound annual growth rate for onshore and offshore wind over the last, I guess, 20 years or so, the average is about 21%, and during the last 10 years or so, it's been averaging about 12% compound annual growth. Moving on to more specific, and if you can see the figures there, 651 gigawatts globally, of which 29 gigawatts is currently offshore wind. But the offshore wind market is growing even more rapidly. So during the last 5 years, the offshore share of the new installations of wind globally has grown from 5% to 10%. And in fact, by 2024, that share should have risen to 20% of the global wind installations. So certainly offshore wind is going to be here to stay, and we're going to be moving away from fixed bottom technology to floating technology as well. And I'll talk a little bit about some of that technology in a moment. We've got, in the UK here, we've got a 40 gigawatt target now of offshore wind by 2030. And of course, the ScotWind leasing round just in Scotland alone, which will be of interest to companies operating in and around Aberdeen, they're looking at a potential target of 10 gigawatts by 2030. Now, bearing in mind that we've got about 1 gigawatt installed in Scotland today, we've got a huge 10-fold increase in the potential capacity to be installed in a very short period of time. So it's exciting times for the sector. So how can the oil and gas industry get into wind and use wind to actually achieve the net zero ambitions? Just last year, of course, 27th of June last year, it was signed into law that the UK government has set this target of net zero by 2050, and in fact in 2045 in Scotland. So how can we actually achieve that ambition? How can the oil and gas industry play its part? Well, we've already seen a number of the oil and gas players moving into renewables. I'll not go through all of these slides here, but just a couple of highlights. Obviously, DONG, Danish Oil and Natural Gas, a few years ago in November 2017, they became 100% dedicate themselves to become a 100% renewables company. We've also seen very more acquisitions and mergers and takeovers. And of course, recently you've had companies like Shell taking over the French floating wind developer Eolfi. And there's a few other examples on that slide that you can read for yourselves. I'm assuming that the slides may be available after the presentation, Martin, if anybody wants them. This project here was one that I was working on or was supporting during my time at DNVGL. It's the win-win water injection, win-win project from DNVGL. It's a joint industry project, and it's looking at wind-powered water injection for oil and gas platforms. Now today, in order to do water injection, you're looking at 3 barrels of seawater needs to be injected after it's been processed into the well for every oil barrel that's produced. Obviously, that's incredibly energy intensive. So the concept behind this project was basically to use floating wind turbines that can be redeployed potentially, once you finished in one particular location, you can move the wind turbine to another location. So over a life of a typical wind turbine, perhaps 25 years, you could actually relocate that turbine to support other oil well recovery systems over its lifetime. So it's a very efficient way of actually getting that water injection and decarbonizing, removing the gas-powered injection methods that are used today. Another area is obviously offshore wind to hydrogen. So with floating wind turbines or even fixed bottom wind turbines in the right locations, you could have an offshore green energy production facility, essentially making pure hydrogen and oxygen from desalinated seawater. And that produces an extremely efficient method of getting the hydrogen. One of the problems with electricity, of course, you can't predict when the wind is going to blow, although it does blow typically offshore most of the time, and most offshore wind turbines now are getting capacity factors between 50 and 60%. You can't guarantee that all the time. So hydrogen provides a method of storing that energy in a convenient way. So this first scenario, these slides are courtesy of the Global Wind Energy Council, but this is looking at water for purification plant, an electrolyzer, a compression of that hydrogen and storage, and then of course a tanker or a vessel can take that produced hydrogen away. Of course, vessels can be quite expensive, and they're not particularly, just getting that energy back to shore is potentially quite an expensive method. So there are also projects looking at doing the the electrolyzing onshore, where you can just ship the final product from the hydrolyzer into a hydrogen pipeline or via tankers onshore, and that would obviously reduce the energy costs of transmission. And then the third option would be to use floating wind turbines with perhaps an existing oil and gas platform and retrofit those with a water for purification and an electrolyzer plant, and actually then inject the hydrogen directly into the existing natural gas network. It is considered that approximately 20% mixture of hydrogen should be possible. So some exciting opportunities there for the oil and gas sector to engage in the wind industry. These slides have been very kindly given to me by Arc Solutions. So one of the areas that oil and gas companies have got readily transferable technology and skills is we've been, for many years in oil and gas, we've been developing and designing floating technology and mooring systems and anchor chains and umbilicals. And all of that information that we've gathered over those years can be readily transferred across to the renewable energy sector. So I do see over the next 10 years, as the renewables grows at this kind of exponential rate, many oil and gas companies will have a huge part to play in actually helping with the design and fabrication of some of these floating structures and the umbilicals. So I'm just going to move on to now our own company's transition into the renewable energy network. If you look at historically, oil and gas was the mainstay of the NIG Energy Park. Back in 2000, however, we built the last of our major structures. So from 1974 to 2000, you can see we did a huge number of projects. Unfortunately, that all dried up in 2000. And for about 11 years, the yard was pretty much mothballed. There was very little going on. So Global Energy Group has gone through a stage process of actually getting into renewables. Where we are today is probably stage 2, where we are now a strategic wind farm construction, manufacturing and marshalling port. Stage 3 is where we're actually going to start manufacturing the towers and the suction anchors, so large diameter steel tubes, which can be used for floating foundations or both for the oil and gas and the nuclear sector as well, of course. And then stage 5 is where we move into some of the scenarios I've just pointed out, which is the electrification of wind and the design and the fabrication of some of these oil and gas platforms to incorporate hydrogen production facilities. So this is a future area where Global Energy Group would be delighted to talk to companies that might be on the call today. If you've got projects in mind, then we'd certainly be keen to have those discussions. So this is how our yard looked in 2011. As you can see, it was pretty much dilapidated and it hadn't had any investment for a number of years. So in order to make it fit for renewables, we spent a significant amount of money on the facility, basically tidying up the sheds, waterproofing them, repainting them, and making the area a place that was going to be pleasant to work in. Obviously, in order to accommodate the jackup installation vessels that offshore wind projects use, we needed to strengthen the hardcore on the loadout areas around the quayside. So we've got 50 tons per square meter of hard standing capability right up to the quayside edge. We also extended the facility with an additional finger quay, which you can see in the top right of the corner of the picture. And we've invested about £40 million in additional plant and equipment. So we've got a very large crane, we've got SPMTs and other mobile cranes that we can use around the site. So it's the site is fully, more or less capable of doing all of the operations required for a wind farm project without having to bring in external equipment. This is the view here just in 2020 when we were installing the Beatrice project. And one of the issues that we do have, as you can see, I'll just turn my mouse pointer on for a moment. you can see that we've got the dock gates are moored outside of the front of the quay on 2 dolphins. So this was a bit of a problem for navigation for some of the vessels. So one of the things we're doing is we're going to relocate those dolphins to the other end of the jetty. And we've also recently acquired the land to the east side of the quay, so locations 6 and 7 there. That will give us access to additional laydown areas and allow us to run consecutive projects. In addition, the land at the top of the facility, I'll move on to the next slide, you can see the former Beatrice oil terminal here. Well, the lease on that comes up for renewal. I think it's in 2025. So once that is expired, we will, and that's no longer used as an oil storage facility. So that land will also become available to us for using for the support of the renewables projects. We've been involved in renewables for quite a long time now. So we started with the Scrooby Sands project back in 2004, and we did a number of offshore wind projects prior to the Beatrice one in 2018, 2019. We're also involved in many offshore wave and tidal projects. And of course, wave and tidal potentially could also support the oil and gas sector, particularly waves, because in the North Sea, as we're aware, we've got very strong wave conditions. So there are projects looking at using wave energy converters as well to support these types of platforms. So these are just a couple of additional slides of some of the projects we've worked on, tidal demonstrators and the Oyster Wave Demonstrator project. And then, of course, leading up to the original Beatrice demonstrator project, and then finally the wind turbine staging port for the Beatrice offshore wind farm project. When we did the Beatrice project, we had to also then get our staff trained, because our oil and gas staff hadn't really had the training in renewables, so the ability to do the working at heights for wind turbines. So we did a lot of work basically on training, working at heights training, and as part of the Beatrice project, we were involved in significant work after the project or after the wind turbine components were installed offshore, doing inspections and maintenance activities. So we've really transitioned our workforce to become a multi-skilled workforce to support oil and gas, nuclear, and of course the renewable energy sector. So just in summary, we've spent already over £50 million on the facilities and £40 million in new plant and equipment. And the next stage of our development is to have an extension to the facility to produce rolling facilities, to produce wind turbine towers, wind turbine suction anchors for floating wind turbines, and also, of course, the tubular sections that we would use for floating wind turbine floaters. So that's the outline there showing you the proposed new factory. Many of you will have seen in the news, we've just started the new campaign with the Moray East Offshore Wind Farm project, which will run through till 2021. This is for the staging port for the offshore wind jackets. So that's also an extremely exciting project for Global Energy Group, and is really going to cement our position as one of the world's leading ports for offshore wind renewables. And hopefully it will lead to much more work in the future. So finally, I'd like to play a very short video. It's just 3 minutes long, which gives a quick overview of what we're planning for the next stage of our transition into this new energy sector.
I'll maybe sit in there, Ian, and then just ask if we can maybe drop the video. We just busted our 20-minute...
Apologies for that.
Sure, yeah. It's a fascinating presentation, absolutely brilliant. I think this is maybe something that we could post online and people...
Yeah, I'll skip through this is my last slide anyway, so I'll skip, I'll just leave that up there. If anybody is interested on the call in joining us as part of this energy transition, please contact Stephen Thompson, who's the Business Development Director for Global Energy Group. I'm sure he'd be delighted to talk to you. Thanks ever so much for your time. Sorry for running over a little bit.
Not at all. No, thank you for a brilliant presentation, Ian. That was absolutely fascinating. Now we've got 20 minutes for Q&A. I see a hand raised already, so thank you very much. I will hand over to you, Tim, and let you ask a question.
Hi, Tim.
Hey, Ian. Thanks very much. Tim Walsh, Oceaneering. Thank you for that excellent overview of how you see the sector and your experience in that, and also for sharing your personal journey as well. I think that's throws a kind of very much different light on things in terms of how you see it. The question I've got, really, given the experience you've got, many organisations that are working in oil and gas and have done for a long time can see how, particularly from the point of view of technical services, how their capabilities have application in the renewable sector, and how they have transferable skills and transferable technologies. But a number of organizations really struggle with the transition. And I was wondering, excuse me, if you could share from the, the benefit of your experience of what you see the key differences between, if you like, traditional oil and gas and the renewable sector are, and your experience of dealing with those key differences in terms of how you deliver the business and how you undertake the business.
Sure, yeah. I mean, there are certainly a lot of synergies between oil and gas. Many of the operations that you conduct offshore are very, very similar to what you would have in the wind energy sector offshore. However, there are also some differences. So, for example, if you look at the design and development of floating wind turbine foundations, they don't behave in the same way as an oil and gas structure would behave, because the structure that's on the top there is actually designed to capture the wind, and you've got these hydrodynamic loads and forces which behave very differently to an offshore oil and gas structure. So, that's just one example where organizations would really need to learn to use some of the software tools that have been developed in the wind energy industry. Well, there are tools from companies like BNBGL, for example, Bladed. Not trying to advertise, but it's one that I'm familiar with because I used to work for them. But those tools are, full multi-body hydrodynamic analysis tools for designing those types of structures. The other area, I guess it's, there's a bit of a fear, uncertainty and doubt in the oil and gas sector. They think that the renewables industry is a hard industry to get into. To some extent, it has got harder. I think because we're now a mature industry, over the last 10 years, offshore wind has really taken off, and we've got massive amounts of experience. We've got really experienced companies like Ørsted who are building large numbers of projects and very successfully with very good track records in safety and so on. So it does make it more difficult if you've got no track record to get into the sector, but that's certainly not a reason not to try and get into the sector. I think the most important thing is to really just engage with the industry, maybe go to some of the renewables events and go and meet and talk to some of the people, go to the Global Offshore Wind Conference that's held every year by Renewable UK. Go to some of these wind events and actually just go and talk to the organizations. I would suggest that that's one way forward, Tim, to get involved. I don't know if that answers your question.
Yeah, it does. I mean, I've actually had some experience in the renewable sector, but I'm very interested in seeing how oil and gas companies, or companies that have even like the majority of their business in oil and gas, actually make that transition, because I think there are some examples where that's worked very well.
Yeah.
You mentioned Dong, particularly from the point of view of an operator, and actually your own experience in terms of more of a service and products providers. But I think there are many that really struggle with trying to make that transition for various reasons. But I think you've hit a couple of things there, and appreciate the feedback in the comments.
No problem. Thank you for the question.
Yeah, thanks, Tim. We've got a question coming in through the comments, through the chat from Stephen Shield. I'll just unmute you, Stephen, so you can ask it yourself personally.
Are you there, Stephen?
No, I'm just trying to unmute him. Sorry if
okay.
I've lost him.
That'll work. Can you hear me?
Yes, I can. Hi, Stephen.
Okay, thank you. Hi, thanks for a really good presentation. Very, very interesting. I was just wondering what the impact of the company's transition to the renewable industry has had on your own supply chain. So have you had to encourage or support your suppliers to invest in new ways of working, or to provide new services and maybe even develop new technologies?
Yeah, actually, one of the slides I think actually had a bullet point on that. I think during the Beatrice offshore wind farm project, we actually engaged with about 120 companies in the local supply chain who were delivering all sorts of additional services, ancillary services. Some companies needed to obviously get retrained in order to accommodate that, but certainly we see the local supply chain around the port of Nig as being absolutely crucial to support our endeavours to get into renewable energy. So yeah, there's There's potential opportunities for training to be done on our facilities as well in the future. And we've got a training academy already, which is a not-for-profit organization. So we are providing training on site. We've also on the facility, I didn't mention this in the talk, but we've created an accommodation facility so that whilst the project is ongoing during construction, we can accommodate there are about 90, I think it's 95 or 98 personnel in accommodation, fully serviced. So that means that people don't have transportation or hotels to worry about getting to work every day. So we've invested a lot in our own facilities, but we're also investing in the local community and trying to roll out the benefits of this energy transition to everybody.
Super, thanks, Ian. I've got one supplementary then. Have Global done any work to understand its own carbon footprint on the site?
Yeah, it's a very good question. And I was actually on a call just 2 days ago. And it certainly is an area that Global Energy Group is looking at actively now is, what is our carbon footprint for our operations within the site? So you'd have to refer back to the directors of the company to find out what the plans are. But I would hope, certainly my ambition for the site would be for them to maybe incorporate solar panels or, to get some of their energy, from renewable energy sources. There's all sorts of things that could be done. It's just making sure that whatever you do it's not just greenwash, it's actually there to provide a tangible benefit. I think in the past, if you look past the last 10 years, there has been an awful lot of greenwash in this industry. And I think we're starting to see the end of that now. People are actually doing real projects that provide real benefits and real value, and large scale projects as well. And this is the key thing. As we upscale the project sizes, the cost is coming right down. So we're already at a cost of offshore wind of around about 36 pence per megawatt hour. And it was £140 just 3 years ago. So that's how fast the costs are coming down.
Great. I see Keith Hogg with his hand up, so I'll hand over to Keith now. I'm sorry, Keith, I'm having trouble unmuting you. Can you try and unmute from your side?
Oh, yeah, that's me. Hi, Ian. Can you hear?
Hi, Keith.
Hi, sorry about that. Yeah, so my question kind of follows on slightly from what Stephen just mentioned there, and looking at the more holistic view on net zero and speaking about supply chains. Now, obviously, a lot of the to have any green energy, you require infrastructure, and wind being no different. You're using quite a lot of steel and manufacture of wind turbines. And steel production itself has quite a large impact on CO2 emission. So I'm just wondering, do you leverage your supply chain to look at companies that have maybe carbon capture and storage facilities when they're producing their steel? Because I'm just thinking to try and encourage I guess steel manufacturers to have carbon capture and storage if they see large companies like your own that are preferentially awarding contracts to them have carbon capture.
Yeah, thanks for the question. And it's a very good question because it's certainly an area that we're very conscious of, that, if you're bringing offshore wind structures halfway around the world, to install them in UK waters, that's not a particularly carbon intensive operation in itself. The maritime transport costs and the carbon emissions from that are something that the UK government is certainly keen to reduce. And, they are setting targets now of up to 60% of UK local supply chain content. Now, there are certain components in an offshore wind farm that you just don't have the capabilities in the UK to produce cost effectively. So wherever possible, of course, we would try and look for methods of decarbonizing that as much as possible. I'm not aware that any steel manufacturers are currently doing carbon capture and storage, but it's an area that we would look to in the future.
Mm-hmm. Great, excellent, thanks, Ian.
Great, and Dorothy Burke, you've got your hand up as well. I'll try and allow you to talk.
Hi, Dorothy.
Hi, Ian. Very interesting presentation. Thank you very much. I was wondering about, obviously, the turbines themselves seem to be, out with the UK, but I think in terms of some of the other services, obviously you're a great example of how some of the UK services can be captured by a UK group. Do you think in terms of foundation types and transition piece design, do you think there's advances to be made by innovating these technologies? There seem to be in quite early stages in the different technologies around the world.
Definitely, yeah. I mean, there are some designs out there for TP-less wind turbines, so they do away with the transition piece altogether. That obviously has a significant saving on steel and obviously the time to manufacture the turbine. So we are looking and talking to companies that are investigating those types of technology. I see floating wind as being really the next major step. I mean, floating at the moment is only restricted to demonstrator projects, but we're starting to see, and certainly with the ScotWind leasing round, we're going to see a number of developers will be putting forward bids for floating wind farm projects in and around the Scottish waters. So certainly floating is an area where there are significant advances to be made in terms of the reduction in the amount of steel that's used. That will obviously reduce the carbon emissions from the manufacturing and production of those components. But we want to be part of that supply chain. We want to be actually manufacturing those things in the UK. We don't want to be bringing those structures halfway around the world. So that's one of the reasons why Nigg Energy Park is investing probably around about 50 million or maybe upwards of that in this new plant. We obviously require support from government to do that. I mean, we're not especially with the current oil and gas situation, it's going to put a strain on cash flow for any company that operates in the oil and gas sector. So we're hoping that the government is going to help us, and make this a reality. And we certainly want to see manufacturing in the UK. We currently do have blade manufacturing in the UK, of course, down in Hull. But this will be the first offshore tower manufacturing facility of its type, as far as we know.
That sounds like good news.
Hopefully, yes.
Great. Thank you very much.
Great. Chris Banks, you've had your hand up for quite a while. I think you've located your mic, so I'll try and allow you to talk.
Hi, Chris.
Hi, can you hear me?
Yes, I can.
Okay, great. So I'm going to ask the question that's going to be on the minds of a lot of people in Aberdeen at the moment as we begin to feel a little bit more pain again. But so will the renewable sector in the UK have the capacity to replace the jobs that we're going to lose in the oil and gas industry as the basin matures and as companies try to transition away from hydrocarbons?
It's certainly, I don't know if it'll replace all of those positions, but it certainly is going to be a major contributor towards that. I believe on the last round 3 projects that have just been consented in 2019, the one I mentioned there, 30, forgotten the figure now, £36 per megawatt hour or whatever. Those projects are looking to deliver around about 7,000 jobs, permanent jobs to the UK economy. Now with the round 4 projects and the ScotWind leasing round projects, that's going to be extended even further. So, you're looking at a 10-fold increase in the amount of wind in Scotland and a 4-fold increase in the UK nationally by 2030. So there's going to be a huge requirement for skilled labour to build these structures. So I can't put an exact figure on it, but what I can guarantee is that wind is going to be a growth sector for many, many years to come.
Okay, great. I mean, if we're losing 30,000, then every one of those 7,000 counts. So thank you.
Absolutely, yep. And it'll be more than 7,000 with the other rounds that are coming up in the future. I mean, that's just the existing round that have already been awarded. So, if you double or treble that, you're probably looking at a significant number. Renewable UK probably have some figures on that. I don't want to quote out of context because I don't have the figures to hand.
Okay, thanks.
Thank you.
Just maybe to add to that, Ian, if you look at the Committee on Climate Change and their further ambitions scenario, if the UK needs to get to net zero by 2050, we'll need a lot of green and blue hydrogen, we'll need carbon capture and storage capacity.
Yep.
And those are 2 sectors that the oil and gas industry is extremely well suited to move into.
Yeah, it's a good point.
I see Lucy Green with her hand up. I'll hand over the mic to you, Lucy.
Hi there, can you hear me?
Hi, Lucy. Yes.
Hi, Ian. Thanks for your presentation. I thought that was great. I've got 2 questions, if I could. The first one was, we've spoken about wind, wave and tidal, and I just wondered if you saw, if you could explain what you think the role is for solar producing electricity on a global level. And I wondered what your opinion was, perhaps on the infrastructure in the basin to cope with perhaps the production and transport and distribution of hydrogen.
Yeah, well, certainly I didn't really talk about solar, but solar has also got an enormous part to play. In fact, solar is probably, I think going back to the DNVGL Energy Transition Outlook, I can't remember which year it was, but solar will reach something like 10 terawatt hours per year of capacity by, I think it was 2035 or something. So solar's got an absolutely enormous part to play. And of course, there are also projects looking at using solar on things like lakes as part of whole marine aquaculture scenarios as well. So there's some very innovative projects out there. In terms of the question about the hydrogen production, one of the problems with hydrogen production at the moment is it's still quite expensive. The electrolyzers are, the technology is proven, but the electrolyzers are still expensive to produce in volume. Much the same as offshore wind, we've seen huge cost reductions as you scale up the volume of production. As we've gone from 100, the government originally set a target of £100 per megawatt hour by 2020. Now we exceeded that several years ago, and we're now down to something like 36, 37 pence per megawatt hour. We will see the same kind of cost reductions come to scale if we start doing a large volume hydrogen production offshore. So, those costs can come down, and I think they probably need to be about half where they are today to make hydrogen, green hydrogen, cost effective compared to blue hydrogen. Does that answer your question, Lucy?
Yeah, it does. Thank you, Ian. Thank you.
That's great, and that answers a question that Adam Frank had via the chat function. Chris, you've still got your hand up. Do you have a follow-on?
No, I'm good, thanks.
Easy one. Thanks.
Maybe one question from my side, Ian. You mentioned the various oil and gas projects, Magnus and Forties, all the way through to Elgin, that were manufactured in the Cromarty Firth, and that led to sort of peaks and troughs, boom and bust. Do you have any thoughts on how we can try and better manage that as we move towards net zero in the low carbon space?
Yeah, I mean, well, one of the key advantages of renewables is that there is no change in the cost of the raw material for the energy production. It's wind, it's for free. So that stabilizes the actual cost of producing the energy. But what it doesn't stabilize is the market price for energy. So if the oil price is depressed as it is at the moment, it means that renewables is not as competitive as it would be otherwise in the market. And of course, that will then have an impact in terms of how fast projects can progress. So we do want to get away from this cyclical scenario we've had with oil and gas. We just, if the Saudis or the Russians decide to turn the taps on, we get, overproduction, oil prices depressed, we get a slump in the cycle. We know the scenario, but how do you fix that? I'm not sure I've got the answer. I think if we can get to more renewable energy production, as renewables takes a bigger share, the impact of those oil and gas producers will be less in the cost of the raw material of energy. And so you'll see more stabilization of prices in the years to come. But right now, renewables is indirectly affected by oil and gas prices. If oil prices are low, it means wind becomes more expensive. And it's an artificial expense, because wind is actually the cheapest form of energy production today, outstripping any other production. Wind energy onshore is the cheapest form of energy production.
Great. Well, we're just about out of our 20 minutes of Q&A. I'd just like to thank Ian for a very informative presentation and a great Q&A session. I'd like to thank all the participants for joining us today. It was fantastic to have such a large audience. And there is a QR code that you can scan to take you to the next Tech20. It should be on the next slide, and that will be next Friday at the same time. And feel free to head over to LinkedIn to continue any discussions with Ian, and have a great weekend and stay safe, everyone.
Yeah, if anybody wants to reach out to me on LinkedIn for a chat, my profile on LinkedIn is Ian F. Finch, IANFFINCH. Thank you very much.
Okay.